All right, hello. We're going to go ahead and attack 5.6, graphing exponentials. So when we're looking at exponentials, we're going to be looking at this kind of function. We have y is equal to b to the x power. Okay. In many applications, right, we might see it in this form as well, where just a, b, and k are just constants, where b cannot equal to 1. That would also be denoted as an exponential function. When we're dealing with exponentials, right, there's going to be 3 parent functions that you might want to go ahead and memorize and take a look at when referring to, when we do like later stuff with transformations and all that stuff. And also it might be a good idea to go ahead and create a table of values, right? Go and plug in x values to get your y values in order to get a good indicator of what our graph is going to look like. So if I'm looking at part A, right, we have y is equal to 2 to the x. This is when I'm going to go ahead and start plugging in my x values. So let's do when x is equal to 0, right? We have 2 to the 0 power. We all know that's 1. So my first point is going to be 0, 1. Same exact thing. I'm going to go ahead and plug in x for 1. So I get 2. Therefore, I have 1, 2 as my next point. Okay, and whenever we're dealing with exponentials, it's always going to have a horizontal asymptote of y is equal to 0. That is our parent functions. So I can go ahead and fill that in right away. So now we can kind of take a look, and this is what our graph will look like. You see that because of that horizontal asymptote, right, we need to be as close to this asymptote we have right here. It is like a magnet, so it's very, very close. It's never going to touch it, but it's going to be very, very close. And then the other end is going exponentially higher. Okay. The domain is going to be negative infinity to infinity. The range is going to be 0 to infinity. Again, it gets very, very close to 0, but never actually touches it. So it is going to be a soft bracket. In this case, there are no x-intercepts, and our y-intercept is at 0, 1. All right, same exact thing for part B. I'm going to go ahead and plug in my x values as well. So I have y is equal to 3 to the 0 power. That's also 1. So I have 0, 1. Then I have y is equal to, let's say, 1 for x. That's also going to be 3. So I have 1, 3 as my other point. Same exact thing. My horizontal asymptote is at y is equal to 0. And this is what your graph will look like. Okay. So same thing, domain negative infinity to infinity. Range is still at 0 to infinity. There are no x-intercepts in this parent function. And our y-intercept is, again, 0, 1. And then part C, same exact thing. I'm going to plug in 0 for x. That gives me 1. So my first point is 0, 1. Again, I'm going to plug in 1 for x. That gives me 4, so I get 1, 4. Same exact thing. I have a horizontal asymptote at y is equal to 0. And this is what our graph will look like. Okay, our domain stays the same, negative infinity to infinity. Our range still going from 0 to infinity. There are no x-intercepts because of our horizontal asymptote at y is equal to 0. And 0, 1 for our y-intercept. So when we are doing problems later on in notes and in homework and whatnot, right, go ahead and refer to these parent functions. So like I said, right, these are considered the parent functions for our exponential functions. And so this is when we're going to go ahead and dive into some translations and reflections. These are basically the same exact rules, right? Same thing for exponential as they have been for other functions when we were dealing with it last chapter, or when we were dealing with graphing of our sine and cosine, right? It's the same exact thing. So if I was looking at f of x equals to 2 to the power of x minus h, right, this is also going to be going right h. If I have x plus h, we're going left h. If I have 2 squared plus k, right, we're going to go up k. If I have minus k, we're going down k. And then same thing with when we're flipping over the x and the y-intercept, right? If it's outside and not touching the x, this one's actually going to be flipping over the x-axis, right? This one is attached to the x, so it's kind of the opposite. We're going to go ahead and flip over the y-axis. Okay. So let's go ahead and actually do some examples. So it says example 1, graph each of the following functions. Whenever you're graphing these guys, I would go ahead and try starting with graphing the parent function. So if I was looking at part A, my parent function is going to be y is equal to 2 to the x. We found out that's what it looks like. Right, it looks like we're not going up or down at all, so my horizontal asymptote is going to stay the same at y is equal to 0. It looks like we have a negative that is not attached to the x, so it's kind of going to be the opposite, and we're going to flip over the x-axis. So this guy is going to move down there, and then this guy moved down here, and this is what we look like. Domain is still going to be the same, negative infinity to infinity. Range is now going to be infinity, negative infinity to 0. The x-intercepts, there still are none, and y-intercept changes to 0, comma, negative 1. Part B looks like we're doing another reflection. Instead, this time, right, it's attached to the x, so we're going to go ahead and flip over my y-axis. Again, with my parent function, it's y is equal to 2 to the x power. And that's what we look like. Okay, we are again still dealing with our horizontal asymptote at y is equal to 0. We're flipping over the y-axis. So 0, comma 1 stays the same for my y-intercept. This guy then changes, and this is what we look like. Still deals with our domain of negative infinity to infinity. Range is still 0, comma, infinity. We still do not have an x-intercept. Then you are done. Go ahead and try part C. See what happens. All right, I would go ahead and try rewriting this as 2 to the negative first power to the x power. All right, when we have a power to a power, right, we just go ahead and multiply that out. So we have 2 to the negative 1 to the negative x. My apologies. And what do we know? You just saw that this is the exact same thing. So this is the same thing. Your graph is going to look like this. Yada, yada, yada. And you're going to see, okay, these values are going to be the same exact thing as that guy. Isn't that cool? All right, this is where I'm going to stop the video, and you guys can continue working on D, E, and F on the next video.